Hey guys, here's another example solving for theta. This equation is a trigonometric equation with a higher degree. The degree on the trig function this time is 2. When we solved polynomials in Algebra 2, the degree, fundamental theorem of algebra, tells us that we will have that number of solutions. In algebra, we had real and imaginary solutions. With the real, they were either rational or irrational solutions. Here, we aren't going to talk about any type of imaginary solution at this time, at this unit, at this topic. We are going to solve, and we just have to watch out for, just as a heads up, when you are the person taking a square root in a problem, you need to remember to put all answers, so plus and minus. If a square root symbol is already written on a problem, for example, if you were given the square root of 9, if that was the question that you were being asked to evaluate, the answer is 3. However, if you were solving an equation, x squared equals 9, and it was up to you to take the square root of both sides, you would find that x equals both positive and negative 3. You would have to find all answers. Now, you might exclude an answer if, for example, we were finding the length of something, you might exclude the negative. But if you were doing something with direction, negative might mean left or down, so you may leave it. So you have to remember that. And then the same applies with trigonometry. When we are the ones taking the trig inverse of both sides of an equation, which isn't too heavy or relevant right now, just foreshadowing for future examples, we would have to find all answers. This particular example, they're asking us to solve between 0 and 2 pi. That's a limited area, all right? We're thinking unit circle there. 0 is included with the bracket, 2 pi is not included. We're going to solve for theta using algebraic techniques first, and then we're going to use our knowledge of the unit circle to finish the problem. I'm going to start off by working towards isolating theta. I'm going to add 3 to both sides. Negative 3 and positive 3, we can use the word cancel there. It becomes 0. It cancels out. So we have 4 sine squared theta is equal to positive 3. If this ended up being negative 3, well, we're done. You can't have 4 sine squared theta equal to a negative. You would have no solution and you could move on. However, we will continue on this journey here. Now I'm going to isolate sine squared theta by dividing both sides by 4, since division is the inverse operation of multiplication, and the 4 is attached to that sign with multiplication. This is called simplifying or reducing. It becomes a 1. Do not call that canceling. We are left with sine squared theta equals 3/4. Leave it as a fraction. Now from there, it's important to know that this notation that we write in our notebooks really means the sine of theta quantity squared. That's actually what that means. We do not ever write sine of theta. Well, I mean, I guess anything's possible, but squared like that, because based on the order of operations, that would mean that you would square the angle measure and then you find the sine of that afterwards. And that's not what we're doing here. We're going to find the sine or ratio of the opposite to hypotenuse as it relates to a certain angle, and then you square that output, all right? Now, in order to get sine theta alone, to peel off that next layer of math that's on top of it, we're going to go ahead and we're going to take the square root of both sides. As I mentioned just a few minutes ago, when you're the one taking the square root yourself in a problem, sine theta equals, you want to use positive and negative answers, unless for some reason you could exclude it. When you take the square root of a fraction, you simply take the square root of the top and the square root of the bottom. You do not bust out your calculator. The square root of 3 is literally just the square root of 3. That is the more exact, the more precise answer. Then the square root of 4 is 2. So really, using the unit circle, we're going to figure out 2 different solutions. I want to know the sine, opposite of our hypotenuse, it relates more to the y values, of what angle equals positive square root of 3 over 2. And I want to know the sine of what angle is equal to the negative square root of 3 over 2. A big red flag when I'm grading papers is when students have a bunch of different answers and they all have different denominators. That's not going to happen, okay? When you have these same ratios over and over, your answers should all have the same denominator, okay? So theta equals sine of what angle equals positive root 3 over 2 if you need a visual. You shouldn't have to look at the entire circle. Here's my y-axis. On the unit circle, it goes as high as 1, as low as -1. Root 3 over 2 is the biggest ratio on the unit circle aside from 1. So what angles correspond to when the y value or the sine is equal to positive radical 3 over 2, and which angles correspond to when the sine or the y value of the ordered pair on a unit circle is equal to negative radical 3 over 2. If you've heard me explain this stuff before, you know that I like to say the pi over 3s are tall and skinny like a tree. So those are my pi over 3s. 1 pi over 3, 2 pi over 3. I don't mean 3 pi over 3. 4 pi over 3 and 5 pi over 3. Here they're positive because the y value went up. So theta for that is pi over 3, comma, 2 pi over 3. And for this, we said this was 3 pi over 3, in other words, pi. 4 pi over 3, 5 pi over 3, that's 6 pi over 3, or 2 pi. Those are your checkpoints, right? So I'm going to also list 4 pi over 3, and I'm going to list 5 pi over 3 as well. So we have 4 solutions on this particular interval between 0 and 2 pi. So we're done with this problem. If we were finding general solutions, that would be a little bit different, and we'll save that for a different lesson, different video. So that is all you have. My advice is also to try to either list your answers in order from least to greatest. Try to also, if necessary, maybe you want to indicate, these 2 answers came from that equation, these 2 answers came from that equation. This way, if you messed up something, you know which answers you need to fix or take care of, okay? So I hope that this was helpful. If you understand, you can just inventory and log this as I get this example, I'm good to go. And if you don't understand, you can maybe acknowledge that you don't understand, put a thumbs down on it. So when you come back later, you're like, wait, I didn't understand this. Maybe I'll understand it now. So that's solving by taking square roots. Also, before I forget, you also could have solved this by factoring using the difference of 2 squares and conjugates. I'll talk about that another time, but just so you have that in the back of your head. All right. Hope that was helpful. Have a nice day.